Okay, this is going to be the first lesson in the limits unit. I want to bring us back to a concept that we worked on in the past where we tested continuity. A little bit different than continuity is we're going to actually test the limit, okay? And what we're going to do is we're going to use a table, all right, or to evaluate these things, okay? All right, so what I want to do is I want to pick something close to 3, so 2.99, 2.99, 2.9, and then 3.001, 3.01, 3.1, okay? All right, now, I want to look at these things as they get closer to 3, all right? So 3.001, you could use a table for this if you want. I'm just doing this because I think this will be universal as far as the calculations go. So that's like 2.0, okay? 2.00, right? 3.01 squared minus 3, 3.01 plus 2, 2.03, and 3.1. Right, so as you can see, this is getting closer and closer to 2. Now let's go the other way. Let's do the 2.99. 2.99, 39 squared minus 3, 2.39s plus 2. That's 1.99. Okay, and then 2.99 squared minus 3 times 2.99 plus 2 is 1.97, and then 2.9. Right, 1.71. Now, as you can see, both of these are approaching, and they approach the same number as 2. So the concept is the limit as x approaches 3 is 2. Okay? Right? So that's how you do that, right? You're looking for the same number to be approached from both sides. We don't have to worry about evaluating 3, okay? All right? So let's take a look at these. So what I would do is like 3.99s, 3.99, 3.9, okay? 4.001, 4.01, 4.1, okay? All right? So what I got is, I'll do the absolute value stuff first, okay? So 4 plus 3.99, all right, 7.99 divided by 3.99 minus 4. Okay, it's negative 7999, okay? All right, 4 plus 3.99, all right, divided by 3.99 minus 4, negative 799, and then 3.9 plus 4 divided by 3.9 minus 4. That's negative 79. All right, so it's sort of really rising very rapidly in the last couple of ones. Now let's do the other one, 4.001 plus 4. Divided by 4.001 minus 4. All right, 8,001. Okay, now let me just do one more just to show you. All right, 4.01 plus 4 divided by 4.01 minus 4. All right, it's 801. So this one, as you can see, is I could fill in the last one if I wanted to. But the bottom line is, if you look at this one's getting closer to 8,000, and this one's getting negative. So when they don't equal each other, or they're not approaching the same number, this does not exist, okay, as far as a limit goes. So that's sort of the exist, okay? That's sort of the concept of limits, okay? All right, is that you want to be getting about the same number coming from each way. We'll talk about more in a second. Let's get to the piecewise concept, okay? So we'll evolve that around 2 here. Okay, so let's say I got 2 I got 2.001, 2.01, 2.1. Then I got 1.999, 1.99, 1.9. Now you gotta be careful of which one you evaluate, okay? All right, for these are obviously the ones that are less than that. Okay, so I would do 1.99 plus 4 gives me 5.99. Okay, 1.99 plus 4 gives me 5.99. And then 1.9 times 4, or plus 4, sorry, is 5.9. Okay, so I got that from that angle. Now let's go from the other one. Now for this one, I'm going to go ahead and use this formula to help me. Okay, so what I would do is 2.001 squared plus 1 is like 5 point something. Sorry, this should be a 3 here. Okay, so that's just going to change to 4.99. All right, that's going to be a 3. Okay, that's a 3. All right, and then 2.01 squared plus 1 is 5.04, and 2.1 squared plus 1 is 5.41. Now, as you can see, this is getting closer to 5, and this is getting closer to 5. So the limit as x approaches that is going to be 5, okay? So you just gotta watch what you're evaluating with that. So what I would like you guys to do is go ahead and make 2 charts for this one, okay? All right, so for this one, I'd make a chart at -2, -2.001, -2.01, -2.1, -1.999, -1.99, -1.9, okay? So just simply evaluating this, all right, -1.99, 3 nines, squared plus 5 times -1.99, 3 nines, all right, plus 4 gives me -0.199. Okay, all right, do the same thing, -1.99 squared plus 5 times -1.99 plus 4 gives me -1.98. And then -1.9 squared plus 5 times -1.9 plus 4 is -1.89. Okay? All right, so I would do the next for -2.01. -2.001 squared plus 5 times -0.2001 plus 4 gives me -2.0. Okay, and then do the same thing. Okay, -2.0 and then -2.1 squared plus 5 times -2.1 plus 4, right, -2.09. So the concept is you're looking, they're getting closer and closer to -2. So this result here would be the limit would be -2. That's what it's approaching. Okay. All right. Let's go ahead and work with these. Okay. So what I would want to do. All right. I got 3.001, 3.01, 3.1, 2.99, 2.9, 2.9. Okay. All right. So. All right, what we want to do, all right, is for these numbers less than this, we're going to use this formula, okay? So 2.999 squared minus 2, okay, is 7 or 6.99. All right, 2.9 squared. Minus 2, 6.94, and then 2.9 squared. Minus 2 is 6.41, okay? So it's getting closer and closer, to 7. Let's check the other way. So for this one, we're going to use this formula, okay? Now, watch what happens. 3.001 plus 6 is 9.001, and then 3.01 plus 6 is 9.01. Now, as you can see, this is approaching 7, this is approaching 9, so this one would be, this limit would does not exist, okay? So it's got to be approaching the same relative number in order for there to be a limit. So that's what we used to do, okay? This is what we did in the past, okay? All right? Now, what I want to talk about is how to look at limits graphically, okay? Now, before we do that, let me insert a blank page here, and let me talk about limits, okay? First of all, you're going to see, like for example, you're going to see things written like this, and it looks a little bit weird. Let's say 7 with a plus, limit 7 as x approaches 7 from the minus, and the limit as x approaches 7. Let me talk about what this means. When you see the sign after this, this means approaching from the right. This means approaching from the left. Okay, that's what that means. And this means just 7 in general. Okay, now, here's something that's very important to understand graphically. The limit of what x approaches from the positive side has to equal the limit that x approaches from the negative side. Okay? All right? If it does not, the limit does not exist. Okay? So what you want to look at is how, when it gets really, really close to that point, what is it about? Okay? What is it about? All right? So let's look at this example here. Okay? We're going to go through a bunch of these graphically. Okay? So what I want to do is when it says, what is the limit as x approaches 1 from the negative direction? Okay, so here is 1 from the left side. It's getting really, really close to about 3. Okay, it's just to that left side. Okay, now what about from the 1 plus side? From this side also, it's about 3. So what does that mean? That the limit as x approaches 1 is 3. Okay, that's how you do that. If they're both left and right are the same, then that amount is that limit. Okay, that's how easy that is. Okay, now sometimes people get confused because you have an open circle. All right, so as x approaches -2 from the negative side of it, this will be right here, that's going to be about a y of -2. Okay, now if I go from the positive side, it's also at -2. Okay, now the limit as x approaches 2 is just going to be -2. Now someone will say, Mr. Evans, when I'm at -2, it jumps to that. That is different. Okay, that's what the function evaluated at that is going to be. That answer here would actually be, what is that? 1, 2, 3, 4, 5, 6. That would actually be -6. Okay? The limit and the function, all right, and the evaluation aren't always the same. Does not mean the limit is incorrect. Okay? Let's look at this. The limit as x approaches 3 from the positive side. Now, from the positive side, it would be about right here, getting close. That's 1, 2, 3. That's -4. So approaching from the positive side, I would have about -4. Approaching from the negative side, look at this. I'm about 2. So what does that mean? These two are different, so the limit as x approaches 3 does not exist. That doesn't exist because those two amounts are different, okay? Now, we already found this. What is f at 3? F at 3 is going to be where that filled in circle is. It's going to be at 1, okay? So that's how you sort of do the positive and negative limits graphically, okay? All right? So what I would like you guys to do is go ahead and pause your video. I'm going to have this in Go Formative. All right? You can answer all of these questions, okay? All right? Go ahead and unpause. All right? The limit as x approaches -2 from the negative side, that'd be here. That's going to be about a value of -1, okay? X approaches -2 from the positive side, that'd be about here, still at -1. So what does that mean? Since they're both the same number, then the actual limit that it approaches in general will also be -1. All right, let's look at x approaches 0 from the positive side. All right, 0 from the positive side. That would be close to 2. All right, x approaching 0 from the negative side, all right, that's going to be about 0. All right, so what does that mean for this limit in general? That it does not exist. Why doesn't it exist? Because the sides from each way does not have the same number, okay? Let's look at the limit as x approaches 4 from the negative side. Okay, here's 4 from the negative side. That's still 4. Let's approach from the positive side. That's also going to approach 4. So the limit as x approaches 4 is just 4, okay? Let's evaluate f of 2. F of 2, all right, that is a filled-in circle at -2, okay? F of 4, if I evaluate that, that does not exist. Does not exist, because it's an open circle and there is no other filled-in dot for that. So that's how that would work graphically, okay? All right, now let's talk about asymptotes, okay? This is a little bit unique, okay? All right, two types of asymptotes. As x approaches -2 from the negative side, this is going up. So when the arrow is pointing up and it's going on forever, that would be positive infinity. As x approaching -2 from the positive direction, that would be this side. That's also pointing up, so that's also going to be a positive infinity. So the x that approaches -2, all right, that's going to be, it's going to get closer and closer to infinity, okay? All right, so that's how that would work, okay? All right. Now, let's look at this, a little bit different of example, okay? As x approaches 3 from that side, this would be positive infinity up here, because this is the left side of it, so that'd be positive infinity. All right, if it approaches from this end, it's going down, so that would be negative infinity. So what does that mean for the limit in general? This does not exist, DNE. Why? Because those two amounts are different, okay? All right, so, all right, what we want to do, all right, is look at these, all right? And if they don't give you, all right, before we start this, if they don't give you a left and a right, you have to do that on your own to determine it, okay? All right, so when I look at, pause your video, all right, go ahead and see if you guys can figure this stuff out, all right? As x approaches -4, okay, now if I'm coming from this side, that would be -1. If I'm coming from this side, it would be -1. So that answer just is going to be -1, okay? As x approaches 0, okay, so we're getting closer and closer to 0. That's going to be 0 from this end. The problem is when I come from this way, it's going to be 3. So that one's going to be a do not exist, okay? As x approaches 2, okay, this is getting closer and closer to 1 from this direction. And if I come closer right to this, it's also going to be 1. So since it's both going to be 1 on that side, that answer would just be 1. Okay? All right? Now let's look at x approaches 5. So if I work all the way here, that would be, on this side would be 3. And if I work this direction, that would be 3. So that limit there is just 3. Okay? As x approaches 6, from this side, this would be negative infinity, and from this side, it's also negative infinity. So that answer is just going to be negative infinity. Okay? All right? So I think that's a good first unit. The big thing you have to understand is that, let's just do one more thing real quick. All right? Just so we can tie this together. All right? So if it does not matter, we had something like this. All right, let's say this is -2 and this is 1. I just want to be really crystal clear with this. If they say limit as x approaches -2, limit as x approaches 1. What you have to do in these situations is you have to, in your graphicalness, find, if it's from a graph, you have to find about what the values of those are going to be. So here, if I got to approach in my mind, I have to approach from the left. If I do that, we're going to put that at about 3. If I approach from this end, I get real close, that's about 3. So that means since they're the both, that would work for 3. Okay, now if I do that for this one, okay, I would approach from this side, I would get 3. Now, but when I approach from this side, I get -1. So this is a one of them, do not exist. Okay, so I just want to be clear with that. Don't get confused between continuity, okay, and limits. Limits have a lot to do with how the graph is being approached around that area.